And in our lesson today, we are going to revise a question that was posted in the group, basically on time value of money. And after we're done, now we're going to look at the annuity aspect, so that we can be able to look at one or or two concepts under annuity. So the question reads: Sally Kalunga has 10,000 that she can deposit in any of the three accounts for 3-year period. Now, Bank A compounds interest on the annual basis, then Bank B compounds interest semi-annually, and Bank C compounds interest quarterly. Okay, then in all banks, the stated annual interest rate is 4%. Okay, so if you look at this question, we are able to see that the present value, it is a 10,000 there. Okay, that's the present value. Okay, then we also have the interest rate. So the 10,000 there, it's a present value. Then our interest rate, it is 4%. Okay, so kindly take note. For Bank A, we are told that was an annual basis. Bank B, that was semi-annually. Then for Bank C, interest was compounded quarterly. Okay, those are the key areas to take note of. So the question says, what amount would Miss Kalunga have at the end of the third year, leaving all interest paid on deposit in each bank? Okay, so in an event that this Kalunga wants to make an investment, and the person wants to choose in which bank would she deposit her money, so we'll be able to calculate for all the three banks. Then we can be able to advise which bank will be suitable for her to invest her money. Okay, so what is the formula for the future value? So we are told that that future value is equal to present value, open bracket, 1 plus R divide M to the power mn. Okay, so where FVN represents the future value. Okay, then the PV represents the present value. And the R, basically it represents the annual interest rate. So our annual interest rate there, it was 4%, which represents 0.04. Then the present value, in this case, it was 10,000. Okay. Then we have got M there, which represents the number. Okay, the number of times. Okay, the number of times interest is compounded. Annually. Then we have got N there, which represents the period of investment. Okay. So our N is 3 years. Then the M, it depends. If it's semi-annually, the M becomes 2. If it's quarterly, the M it's 3, because in a year there are the M becomes 4, because in a year there are 4 quarters. If it's just annually, that means that the M is 1, okay, because the number of conversions there will only be 1 in that particular year. Okay, so we can solve now for bank A. So we'll start with bank A. So bank A, our future value will be equal to present value, then 1 plus R M there, shall say MN. Okay, so our future value being a 10,000, then 1 plus the rate there, which is 0.04, divide 1. So we shall say 1 multiplied by 3 there. So 10,000 will be 1 plus 0.04 to the power 3. Okay, so this 10,000, when you add 1 plus 0.04, we're going to have 1.04 to the power 3. So our 10,000 there, 1.04 to the power 3. Okay, it's going to give us something like 1.248. Okay. 4864. So when you multiply with the 10,000, the future value after 3 years will be 11,284.64. Meaning, if this madam was to invest in bank A, this is how much she can be able to generate after 3 years. Okay. We will go to bank B. Bank B, we are told that it was compounded semi-annually. So bank B, we shall say the future value is equal to present value, 1 plus C, R divide M, then M N, like that. Okay, so our present value is 10,000. Okay, 1 plus the rate there, 0.04, would divide by 2, because the number of conversions in that year is 2. There are 2 semesters in a year. Okay, the M, that will be a 2 multiplied by 3 there. Okay, so 10,000, 1 plus 0.02 will be the answer when you divide 0.04 divided by 2 to the power 6 there. So 10,000, 1 plus 0.02 to give us C, 1.02 to the power 6. So 10,000 there, 1.02 to the power 6. We're going to get something like 1.1, okay, 2616, like that. So when you multiply with the 10,000, the future value after 3 years is going to be 11,000, okay, 261, okay, 0.6 there as the future value after 3 years. Okay, we continue as we go to to bank C. Okay, so future value is equal to present value, then 1 plus R over M there, then we shall say MN. Of course, our present value is 10,000. 1 plus 0.04 divide by 4. Why are we dividing by 4? We know that in a year there are 4 quarters, so that will be 4 multiplied by 3 there. So we shall say a 10,000, okay, 1 plus 0.01 to the power what? To the power 12. So therefore, this will be 10,000, okay, 1.01 to the power what? To the power 12. Okay, so 1.01 to the power 12, our answer there becomes 1.26825, like this. Okay, so when you multiply by 100, okay, the future value after 3 years will be 11,268.25. Okay, that will be the investment. So from all these 3 banks that we have, we're able to see that at least the rate of return becomes higher in bank 3, which is bank C, as compared to bank A and bank B. So if we're able to advise Miss Sally Kalunga, we can be able to advise her to deposit her investment in bank C, because the rate of return becomes higher as compared to other banks. Okay, let's go to question number 82. Question says, what is the effective annual rate could she earn in each of the banks? Okay, meaning bank A, bank B, and bank C. Okay, so we need to find the effective, okay, annual rate. So what is the formula for the effective annual rate? We are told that effective annual rate is equal to 1 plus R over M, then to the power M minus 1. Okay, where R is the nominal interest rate. Okay, then M, this is the number of conversions or times, okay, interest is compounded annually. Okay, so we'll start with bank A. Bank A, the effective annual rate will be equal to 1 plus R divided by M, and M minus 1. Okay, so in this case we're going to say 1 plus the rate there, which is a 4%, 0.0 divided by 1, because in this bank it was just annually, so meaning the number of conversion will just be 1, and 1 minus the 1 there. Okay, so that is going to be 1 plus 0.04 Okay, power 1 minus 1, that's going to give us something like this, minus 1, and our answer there will be 0.04. So you multiply that by 100, discover that the effective annual rate, okay, will be equal to 4%. Okay, that is for bank A. Now we continue, look at bank B. So bank B, the effective annual rate will be 1 plus R divided by M, then M minus what? Minus 1. Okay, so 1, the rate there is 0.04, divide 2 there, of which we're going to set to the power 2 minus 1, because there are 2 conversions in a year. So we shall say that 1 plus 0.02 to the power 2 minus 1. Okay, that's going to give us 1.02 to the power 2 minus 1. So what do we get there? We're going to have 1.0404 minus 1, which is going to give us 0.0404, like that. If you multiply by 100, you discover the effective annual rate, it will be 4.04%. That's for bank B. Okay, we continue. We go to bank C. Okay, bank C. Our effective annual rate will be equal to 1 plus R over M, then M minus 1. Okay, so it is 1 plus 0.04 divided by 4, because there are 4 quarters in a year, to the power 4 minus 1. That's going to give us 1 plus 0.01 to the power 4 minus 1, and that will be 1.01 to the power 4 minus 1. Okay, that's going to give us 0.0406. Okay, you express it and then minus 1, then you multiply by 100, you discover that the effective annual rate here, it's going to be 4.06%. Okay, that is for bank C. Okay, so what is question A3 saying? The question says, based on your findings in part 1 and part 2, which bank should Miss Kalunga deal with and why? Okay, so looking at our findings there, definitely we'll go for bank for bank C. Okay, so say that based on the calculations based on the calculations, okay, in part what? In part A1 and part A2, okay, our advice that Miss Kalunga should deal with bank what? Should deal with bank C, as it offers the highest, okay, effective, okay, annual rate of 4.06%, okay, with the highest, okay, future value, okay, of 11,268.25. Okay. We continue as we will look at 4. Okay, question A, Roman numeral 4. We are told that if a fourth bank, which is Bank D, also with 4% stated interest, okay, compounds interest continuously, how much would Ms. Kalunga have at the end of the third year? Then does this change your answer in part 3, in terms of which bank would she invest, which bank would you advise her to deposit at 10,000? So compounded continuously. Okay, so compounded continuously, which is Bank D. So Bank D, okay, compounded interest continuously. Okay, so we shall say that future value here, it is a P E and to the power R T. Okay, where E is exponential, okay, P, basically this is the present value, okay, then R, that is the interest rate, then T, we're basically talking about T, the period or the number of years, period for the investment. Okay, so how do we solve that one? So we shall say that future value after 3 years, present value is 10,000. Okay, present value is 10,000. Then the exponential, then the interest rate there that will be 0.04 multiplied by the period, which is 3 years. So 10,000 there, exponential 0.03 multiplied by 0.04 multiplied by 3, that will be 0.12 there. Okay, so future value, if we were to punch that on the calculator, basically it's going to give us 11,274.97. Now the question is, will that change our answer there? Okay, yes, it's going to change. Okay, why? We need to advise Ms. Kalunga to invest his money in Bank D. Why Bank D? Because Bank D has got a higher return on investment. Okay, so our advice is that Ms. Kalunga, okay, should deal with what? With Bank D, okay, because it has, okay, it has the highest return on investment. On investment of 11,274.97. Okay. We continue. Let's look at the B part of the question. So the B part, Sally would want to get a bank loan of 10,000. Okay, she's looking at 5 banks that were willing to give her the loan. The nominal rate for all the 5 banks is 10%, but the compound interest is different as follows. So Bank A, it's annually. Okay, so definitely if it's annually, that means here even the rate itself is also 10%. The effective annual rate is also 10%. It's just the same. Effective annual rate is also what? 10%. Then for the semi, you can be able to calculate it from here, where we are told that effective annual rate, that is 1 plus R divide M to the power M minus 1. Okay, this one is going to give us 1 plus 0.1, that's 10%. Okay, divide 2 to the power 2 minus 1. Okay, if you divide there, the 1 plus 0.05 minus 1 should be 1.05 to the power 2, okay, minus 1. So if you express that one, where we have the 1.05 to the power 2 and minus 1, and multiply by 100, you discover that we're going to have 10.25% as our annual effective what? Our effective annual rate for Bank B. Okay, you can go on and look at Bank C. Bank C, which is quarterly. Okay, so Bank C, the formula is still the same. M there minus 1. So here it will be 1 plus 0.1 divided by 4 to the power 4 minus 1. 1 plus 0.4. So 0.1 divided by 4, our answer will be 0.025 to the power 4 minus 1. Plus 1 there. Okay. Then to the power 4, then subtract a 1. That one is going to give us a percent. The effective annual rate of 10.38% if it's compounded quarterly. Okay. We go to bank D. Okay, bank D. Here it is 1 plus plus R over M then M minus 1. Now this is compounded daily, meaning that is 365 days. Remember, there are 365 days in a year. So 1 plus 0.1 divide 365 to the power 365 minus 1. So if you divide 0.1 divide 365, then plus 1, then the power of 365, okay, then minus 1, then you multiply by 100. Okay, you are going to have something like 10.51, 10.52, 10.52%. Okay, then for the last bank, which is continuously, okay, bank E. Here it is exponential rate minus 1. Okay, our rate is 0.1 minus 1. So if you punch that one, going to say bank E, okay, in effective rate, okay, effective annual rate. So exponential to the power 0.1 minus 1, then multiply by 10. So by 100, it's going to give us also as 10.52%. 10.52%. So as you can see, the question is saying, with the support of proper calculations, advise Sally on which bank to get the loan from and give a reason for your answer. Definitely, if she was to get a loan, she would love to get a loan from the bank with the lowest the lowest effective annual rate of return. Okay, so after this calculation, okay, Miss Kalunga, okay, should get the what? The loan, okay, from bank what? From bank A. His own being is that because it has the lowest, okay, effective, okay, annual rate of 10%. Okay. Okay, so that was it for this question. Now we can now look at the other part, which is the annuity part. Okay. Future values of annuity. Now, before we look at these future values of annuity, let me explain what an annuity is. So, an annuity is a series of equal deposits or we can say withdraws made at an equal intervals of time. Okay, so what this means is that you are either making deposits, okay, you are either making deposits or you are making withdrawals, okay, at an equal interval of time. So meaning those deposits that you are making, they are of the same value, or those withdrawals that you are making, they are all of the same value. Okay. They are all of the same what? Of the same value. So take note, these deposits they deal with the future values, okay, of annuity. Okay, and these withdrawals, they deal with the present what? Present value, okay, of what? Of annuity. So whenever there is a withdrawal, just know that this one is dealing with the present value annuity. And whenever there is a deposit, just know that this is dealing with the future value annuity. Now, apart from us having the future value of annuity and also the present value of annuity, you need to understand something here, that there is what we describe as the ordinary annuity, and there is also what we describe as the annuity due. Okay, so apart from having the future and the present value, you discover that there is what we describe as the ordinary, okay, annuity, or the annuity due. So meaning under the present value, we have got these two types of annuity: the ordinary annuity and the annuity due. Meaning even under the future value annuity, we also have got the annuity due, and we also have got the ordinary, okay, annuity. Okay. Now take note that the present value, basically we said it deals with deposits. So the present value, we said it deals with withdrawals. Withdrawals, that's the present value. But the future value, it deals with what? Deposits. Okay, so all the deposits are future value of annuity. All the withdrawals, these are present value of annuities. Now, what's the difference between the annuity and what's the difference between the annuity, the ordinary annuity, and the annuity due? Okay, because these things, they look to be identical. So take note, okay, that there's a difference between the ordinary annuity and also the annuity due. So the ordinary annuity, ordinary annuity, you discover that here deposits, which is the annuity due, you discover that deposits are made, or payments, would say payments or deposit are made at the beginning, okay, of a period. So here, discover that deposit will be made at the beginning of a period. Okay, deposit. Then here, where there's ordinary annuity, you discover that here that is at the end of the what? Of a period. If it's deposit. Same with this one. Okay, the present value annuity where we're making withdrawals. For the due annuity, you discover that it will be at the beginning, okay, of a period. Okay, ordinary annuity, this is at the what? The end of the what? Of the period. Okay, so that's the difference now. Okay, so we can be able to look at the future value of annuity. Now, what is this future value of annuity? After being told that future value of an ordinary annuity, here payments, okay, payments are being made at the end of a period. Okay, so payments are being made at the end of a what? At the end of a period. So we shall say that future value of an ordinary annuity, okay, basically is a value, okay, that a stream of expected or a promised future payment will grow, okay, after a given number of what? A given number of periods at a stated what? At a specified period of time. So this future value of ordinary annuity, it can be calculated as this, where you say future value is equal to present value, okay, then the compounding minus 1, okay, then divide by what? Divide by R, which is the rate. So where FV is the future value, PV the present value, okay, and R is the rate. Okay, so this so-called the present value, it may also refer to the deposit that's made, okay, the deposit that's made at the end, so at the beginning of at the end of a period, sorry. So the deposit that's made at the end of a period can also refer to the present value. So now, where this PV, okay, it is the present value, okay, present value, okay, present value, or we can say value, okay, of what? Of each deposit. Okay, then the R there, it basically represents the interest rate per period. Okay, then this one basically represents the future value. The future value of an ordinary annuity. So remember, ordinary annuity We're talking about at the end of a period. Okay, so we can look at an example. So the question reads, what amount to accumulate if Dorcas were to deposit 5,000 at the end of each year for the next 5 years, assuming that the rate is 6%. Okay, so the key is at the end of each year. So when you just see that one, just know that this is an ordinary annuity. And then deposit, you know, that deals with the future. Okay, so the formula there we are going to have is that future value is equal to present value. Okay, 1 plus C, and there minus 1, then in the rate. So our future value will be equal to 5,000. Okay, then 1 plus 0.06, okay, to the power 5, since it's 5 years, divide 0.006. So future value there, that will be 5,000. Okay, so if you express that one, going to have 1.06 to the power 5 minus C, 1. Okay, then 0.06. So future value, it is 5,000 there. Now 1.06 to the power 5, 1.06 to the power 5, okay, minus 1, divide 0.06. It's going to give us something like like 5.6 370, okay, 92 and 96. Okay, such that when you multiply that one with the 5,000, okay, you are going to get you're going to get something like a 28,000, okay, 185.46, meaning that will be the future value after 5 years if this person was to be depositing a 5,000. Okay, now there are some of us who would say, me, it will be very challenging to know the formula. Okay, it will be very challenging to know the formula. You can either use the tabular method. Okay, how is the tabular method being dealt with? Okay, we're going to look at the year. Okay, then you begin, then you look at the interest, you'll also look at the deposits. Okay, then you look at the end. So year 1, year 2, year 3, year 4, and year 5. Okay, so at first you don't have anything. There will be no interest also, because you are depositing the money at the end of a period. So if you deposit the money at 31st December, don't expect it to incur an interest in that particular year, because it's the last date. So meaning at the end of the year, you're going to have 5,000 in your account. In second year, the same 5,000 will be balance brought forward. Okay, Are we going to expect interest here? Yes, because it is in the beginning of the year. So 6% of that one, that is a 300 kwacha. Okay. Then you deposit also your 5,000 at the end of the year. Okay, your total will be now a 10,300. Okay. In year 3, you're going to have 10,300 in your account. The 6% interest, that will be 618. That 6% is now of the 10,300. Then you deposit your 5,000. At the end of the year, you're going to have 15,910. Okay. So that's supposed to be 15,918. Then fourth year, you have your 15,918. The 6% of that one to be 955. Okay, 0.08. You deposit again your 5,000. Okay. At the end of the year, you're going to have a 21,873.08. Okay, fifth year, 21,873.08. The interest of that would be 1,312.38. Then you deposit your other 5,000 at the end of the year. Okay, when you add all that, it's going to give you 28,185.46. So this value that we have there, it is the same value that we got. The same value that we got as our future value. Okay, same as this one here. So you can choose whichever method to use. Okay, now that we're done with the ordinary annuity, we can now go to the annuity due. Okay, so this one, it is at the end of the year. What about the annuity due? Annuity due, basically it is at the beginning of the year. So when the year is starting, that's when we deal with the annuity due. So what are we going to say there? We're going to say that the future value of an annuity due, okay, is identical, okay, to an ordinary annuity, okay, except that each payment here occurs at the beginning of a period, okay, rather than at the end. Okay. So how can we calculate this so-called the future value of annuity due? Okay, this is very simple. We can say that future okay, of an annuity due is equal to future value of ordinary annuity multiplied by 1 plus R, which is the rate. Okay, so in this case we shall say that future value is equal to, remember the formula for the future value of ordinary annuity, it was the present value, okay, where we said 1 plus R to the power n minus 1, okay, over what? Over R. Then now we multiply 1 plus R there, like that. Okay. So after we are done with that, we can be able now to fuse in numbers. So how do we solve that one? Let's look at an example. What would accumulate if Lindani were to deposit, okay, to deposit 5,000 at the beginning of each year for the next 5 years? Assume the interest rate of 6% compounded annually. Okay, so what do we do there? Okay. Our deposit, which is our present value, it's a 5,000 there. Then the rate is 6%. The number of years, that's 5. So I just have to fuse in on the formula. Say present value 1 plus that to the power n minus 1. Okay, divide what? R. Future value, present value there, that is 5,000. Okay, 1 plus 0.06, 5 there minus 1, okay, 0.06. The future value, that would be 5,000. Okay, 1.06 to the power 5 minus 1. Okay, that would be over 0.06. Oh, sorry, we forgot the other part there, which is the multiplication of the 1 plus R. So that one will be 1 plus 0.06, meaning 1.06. So if you express what is in the bracket there, where we are told that 1.06 to the power 5 minus 1, then divide by 0.06, we are going to have something like 5.63, okay, 7092, okay, 96 multiplied by 1.06. Okay, so our future value of annuity will be equal to 29,000, okay, 876.59, like that. Okay, meaning if you are depositing your money at the beginning of each year. So if the formula becomes a problem, we can also use a tabular method. Okay, here we are making deposit at the beginning of each year. So if you want to use a tabular method, you say the year there, okay, you begin, then you deposit Remember, since you are depositing, meaning it's going to incur an interest. Okay, then at the end of the year, how much is it going to be? So 1, 2, 3, 4, 5 there. So beginning, there's nothing. Then you're going to deposit a 5,000. Interest on the 5,000, which is a 6%, it's going to give you a 300. Then total would be 5,300. In year 2, your bank balance will be 5,300. Then you deposit your 5,000. Okay. So to be 10,300. Your interest, which is 6%, to be 618. Then you're going to have 10,918. That becomes your balance in year number 3. Then you deposit your 5,000, okay, which will be 15,918. The interest of that one, that will be 955.08. Okay, meaning at the end of the 3 year, you're going to have 16,873.08. Okay, 4th year, 16,873.08. You make a deposit of a 5,000. Okay, your money will be 21,873.08. The 6% of that one, that will be 1,312.38. Okay. At the end of a period, that will be 23,000. Okay, 185.46. This will be your money at the beginning of the 5th year. You deposit a 5,000. Okay. That's going to be 28,185.46. Okay, the 6% of that, that will be 1,691.13. Okay, which will give us a total now of 29,876.59. So this is the value that we got, okay, using the formula. Okay. So we have come to the end of our lesson today. When we meet next time, we'll be able to look at the ordinary annuity and the annuity due based on the present value, and also we'll look at amortization. Thank you for today's lesson. We'll meet next time.